Good morning, everyone, and welcome to today's class. Just have a recap of what we have done in the previous class. I think in the previous class we had seen the series and parallel combination of springs. In series combination, we had seen that extensions are different, but the force which is applied on both the springs is same. If there are two or more springs attached in series, we can replace those two or three springs by a single spring which has an effective spring constant 1 by ks. S standing for series will be summation of 1 by ki. X1 plus x2 will be equal to x, but force will be same in all the springs. That is known as the series combination of springs. We had also seen something known as the parallel combination of springs, in which the two springs are attached in such a way, two or more than two are attached in such a way that their extensions are same, but the force acting on each spring is different, F1 plus F2. If these are the two forces, F1 plus F2 will be equal to total force F. Again, we can replace these set of springs, whether they are two or three or n number, by one spring. The effective spring constant of that spring, Kp, P standing for parallel, will be summation of Ki. The total force will be the summation of the two forces, but the extension is same. We also had seen that if we have a spring cut into half, the spring constant of a spring is inversely proportional to its length. We had also seen an example. I hope you remember this. In today's class, what we will start with is that we will try to do one or two problems in that series and parallel combination of springs. These problems may not come in this chapter of work, power, and energy. This will basically come in the chapter of simple harmonic motion. So basically, we are doing questions of another chapter which is going to come now. Doesn't matter. We have to do it anyways. So why waste time if we are doing something here? I always believe that if you're doing something, do it to the extent that you can do it. There were things previously that I did not tell you because you did not need to know them at that point in time. I only told you what you were supposed to know, and at that particular time I told you. I call it need to know basis. Need to know basis, and I always follow that need to know basis. Right now you don't need to know this, but you will eventually have to find out. So if we are doing springs, why not finish this entire spring completely, so that once done, always done. We don't have to worry about it anytime again. Now you have become mature enough to understand it. So now let us solve one or two problems that may not come in this chapter. That is a there's a problem of the upcoming chapters. Let us try to solve them. If you can solve them now, we don't have to do it later on. So this is the problem that it looks like. I hope you can see my screen, and at the same time that I'm drawing this diagram, you are also drawing the diagram. Now the diagram looks like this: tongue, 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 tongue. I have two springs like this, and then I have one spring attached like this, and this gentleman is attached to a body of mass m. Now what I'm going to do is I'm going to elaborate this problem to an extent where we'll try to apply everything that we have learned about springs in one problem, and I'll give you one more for you to practice. That should be good enough. You will encounter the same problem in the chapter on SHM, but it might not be so elaborate. So in the chapter on SHM, we'll do the part which is a part of SHM. Right now, we are trying to do the part which is a part of this chapter. So what I am going to do here is, I have got, as you can see, three springs. I have got three springs. This spring is having a spring constant K. This spring is having a spring constant K. But the third spring is having a spring constant of 2K. And the question simply is, if I displace this block by an amount x, If I displace this block by an amount x, you have to tell me what is the total potential energy stored in this entire springs. I'm not talking about individual energies right now. I will do the problem in all the possible variations that can come, so that by doing one problem we are actually doing 5 to 10 problems in one problem. Right now I'll start from the most basic one, and the most basic problem here that you will have to solve is finding out the total energy stored in the spring. Or if I just break it out into more basic one, first problem would be, and I'll break it up into small problems, find the effective spring constant of the spring. Now what do I mean by effective spring constant? By effective spring constant I mean, if I can replace these three springs, which I can do, by one single spring, you have to tell me what would be the spring constant of that spring. That would be the first problem. Then I'll make more problems, and I'll make it the problem tough, 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 and I'll make it to the toughest, and I take it to the toughest level. And then I'll tell you, think about the toughest problem. If you can solve the toughest problem, you can solve any of the problems. And to solve the toughest problem, you need to solve all these small problems. So any tough problem, as I've always said, is a combination of small, 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 small steps. Take those steps and you will reach the pinnacle of success. So this is the problem for you. You'll get 1 minute, 2 minutes to solve this. Good luck. Let me see if I have any solution or any answer coming up. Remember, answers are not important. Answers may be right, answers may be wrong. You might do a calculation mistake. There are no right and wrong answers. The only thing that I'm concerned about is that you understand what is to be done in the question and do it correctly. If you do it correctly, answers will come. As I said, there are 3 steps of clearing IIT-JEE. The first thing is applying the right concept. The second thing is applying the right concept, you get the right answer. The third thing is, when you are ready to clear JEE, applying the right concept, getting the right answer, and getting it in the right time. If you are taking 5 minutes for a question of 1 minute, well, you're not going to clear JEE. Your time starts now.
F by 4x.
Yes, bacha, what is the answer?
F by 4x.
X by 4x.
F by 4x, sir.
What are you telling me, beta? What are you telling me?
Sir, K is equal to F by 4x.
K is equal to F by
4x.
what is F? What 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 things are given to you in the question? You are given K spring constant of the 2 springs. You are given 2K spring constant of the third spring. You are given M and you are given X. And now you are telling me the answer is 4F by K, 4F by X. F is not given. So you're giving me the answer in terms of something which is not given, which is a question in itself. So then I'll ask you, what is F? You can only give answer in terms of known quantities, beta. You cannot give an answer in terms of unknown quantities. Am I clear, beta? So the answer should be in terms of the quantities that are given. Quantities that are given are K and M and X. So your answer should be in terms of those quantities, not in terms of other unknowns. So if someone asks you on a lighter note, where is your house? I'll say right in front of your house, in front of your house. Then I'll ask you, okay, where is, let us, 2 people are talking. One is Ram, one is Sham. Someone asks Ram, where is your house? Ram says, it is in front of Sham's house. Well, good, well done. Then Sham says, then the person asks Sham, Sham, where is your house? Sham says, it's in front of Ram's house. Will I ever find out where Ram and Sham are? No, I will never find out. Because they are both in front of each other, I understand that. But where are those two fronts available? Where are those two fronts located? I don't know that. Answer should be in terms of things that are known. So Ram should tell me my address is this, and Sham's house is in front of my house. So if I know Ram's house, I know Sham's house. But I should know Ram's house in terms of known quantities and not in terms of unknown quantities. So can anyone tell me where is Ram's house? Ram's house right now is the value of effective spring constant. No one knows Ram's house? Anyone has an idea? Answers are not important, as I always tell you. I'm least bothered about answers in life. You're not going to get many answers in your life. The process is important when you are achieving, when you are aiming for a target. Getting to the target is not important, because once you get to that target, everything is done. It's finished. The process is important. The journey is important. Answer is the least concern, least of the concern. The process in which you get that answer is important. What is the process here? Anyone can tell me that process? How? Yes.
1/k, sir.
Yes, bacha?
1/k.
1 by k.
Sir.
Just try to make sense out of it. If I ask you, let us forget about k here. What is the value of acceleration? If a is the acceleration, what is the value of acceleration? And you give me the answer that it is equal to 1 by a. Will it make any sense? Or 5 by a or 10 by a? Are they dimensionally equal on both sides? Are they dimensionally equal on both sides? No, na? So, if I have k here, if I have k here, if I have k here, the value of k effective must be in terms of k, some x multiplied by k. It cannot be some x divided by k. It cannot be some x multiplied by k squared. It cannot be some x multiplied by k cube. It cannot be some x multiplied by k squared, because the dimension has to be same on both sides of the equation. That is the very first thing that I taught in the very first class. If you don't remember it, go back and see the class. Dimensions of equation, and that was the topic of the last test that we did. Dimension, unit dimensions. Dimension on one right hand side should be equal to dimension on left hand side. My dimension on right hand side is k effective, and the answer that you are giving me, the dimension on the right hand side, on the left hand side is k effective, on dimension on the right hand side is 1 by k effective. This is not possible in this universe. Come back to this universe where dimensions are same on both sides. So now give me the answer. The first thing that you must see in your answer is that whether your dimensions are correct or not. If your dimensions are wrong, never give that answer, because that has to be wrong. Do we remember this? Yes or no? Please raise your hands. Answer cannot be 1 by k. It is dimensionally wrong. You have not seen what is on the other side of the equation. Answer cannot be 1 by k. Never in this universe. Never in any other universe. Known or unknown. Anyone has an answer? Anyone? See, you're not telling me the process and you are hell bent on giving me an answer. When you don't follow the process, answers are difficult to achieve. Anyone tell me how are you going to solve it? Forget about the answers. Answers are least important. Anyone tell me how you're going to solve it? Anyone knows it? No one? No one knows it?
Parallel for first two springs.
First two springs, let me mark them by green. First two springs are? This says you're going correct. First two springs are?
They are connected in parallel, sir.
They are connected in parallel, no doubts about it. They are connected in parallel. So what can I do with these two springs? What can I do with these two springs? I can replace them by what? I can replace them by what? Another spring.
Chain extension.
Another spring whose spring constant, oops, wrong color, whose spring constant K P will be equal to K1 plus K2. Yes or no? That's the formula that we derived. Yes or no? Do I have raised hand that we understand this?
Yes, sir.
So K plus K, that becomes 2K. Now, if it is difficult for you to visualize, what I'm going to do is draw this diagram again in this blue thing, which is the answer or solution part, and then replace those two springs by a single spring whose spring constant now is 2K. Now the diagram looks like this. This is 2K. How did I achieve this 2K? This 2K comes from the top. This is 2K. This 2K gentleman is already there. This 2K gentleman is already there. So this is this 2K. This is this 2K. Now can anyone elaborate what is happening next?
Series connection, sir. For both.
Yes, these two springs now are in.
Series connection.
So I'll just mark them by yellow. Yellow is not working. Now it is working. These two springs are now connected in series. These two springs are now connected in series. So the effective spring constant becomes. Now this is where you might have done a mistake. Now the effective spring constant of this spring becomes, remember, in the formula we had 1 by K S. Someone gave me the answer of 1 by K. Remember, on the left hand side, you did not have K, you had 1 by K. That is why the answer was coming in terms of 1 by K. And you forgot that small thing. And that is why you gave me a dimensionally incorrect answer, which is not valid. Are you getting my point? What was the mistake in your answer? The answer was
Sir.
correct, but you did not see what answer are you getting. Am I clear? Can I have some raised hands?
Yes, sir.
Okay, so 1 by Ks will be equal to 1 by 2K
1 by 2 plus 1 by 2.
plus 1 by 2K. Now, since you are maths guy, you must be able to understand. Solving this, you should be able to get the value of K. Remember, when you solve this, you will get the value of 1 by Ks, not Ks. So whatever answer you get, reverse it. You reverse it, you will end up having the spring constant, the series spring constant as K. Now, remember, I can give you a shortcut over here. I can give you a shortcut over here. Now, this shortcut is only valid for two springs. What is the shortcut? If I have two springs, the original formula for two spring is 1 by K1 plus 1 by K2. Most of the students do a mistake, the same mistake that you have done, Bicha, that they will always get the value of 1 by Ks, and the value will always be in the form of 1 by something, 2 by something. That is a mistake. So instead of writing this formula like this as equation number 1, remember only for two springs, I can just solve this formula here and write this formula in terms of like this. Ks will be equal to K1 K2 upon K1 plus K2. Now this is the second way of writing the same formula. Now when I write it in this fashion and I solve it in this form, I will straight away get the value of Ks and not the value of 1 by Ks. From equation number 1, I will get the value of 1 by Ks, that I again need to do the reverse or skip or make the numerator denominator and vice versa. Here from equation number 2, which is another form of the same equation, I will get the value of Ks straight away. Do we get this? So this is a shortcut that you can use to find the value of spring constant of two springs which are in series. So effectively, what is your answer for K effective? What is the K effective of this entire system? What is the K effective of this entire system? Anyone? That is simply equal to K. Do we understand this? I can replace
Yes,
these
sir.
three springs. I can replace these three springs by one single spring. Do we all get this? Can I have some raise hand that we understand this? Girls at the back on the right, boys at the back on the left. Everyone there with me? Okay. Now that was the first question that could have been made, but as I constantly tell you, that there can be more questions that can be made. For example, let me make this question here, and I hope it is visible to all of you. Question number 2. Find out the energy stored in the system. Find out the energy. When I say about energy, I am talking about elastic potential energy. Find out the elastic potential energy stored in the system. So I want to find out what the if I move this block by an amount x, what is the elastic potential energy stored in the entire system of these three springs? I'm waiting for your answers on this one. I'll give you a minute. And students in the online class, Karthik, Krishna, Reddy, are you following me? Please raise your hands that you are trying to solve the question. Krishna is there. What about Karthik and Reddy?
Yes, sir. We're solving the questions.
Great, great. If you have any doubts, you can raise your hands. I can see your raised hands and I can come back to you.
Yes, sir.
Good. So the question is, it still remains, what is the elastic potential energy stored in the spring? Do I have an answer for this from anyone?
That 2k x square.
But can you be a bit loud?
2k x square.
2kx squared. I'm afraid that may not be the correct answer. How did you get this 2kx squared? Can you explain? Can you explain how did you get this 2kx squared? Anyone? Or if
Sir,
anyone has any other answer,
after
welcome.
the 4k x square.
4kx squared. Can you explain how did you get it? Again, I always tell you, answers are not important. I can do absolutely rubbish things and get you the answer. I'm a expert in doing that. There was a point in time then in the year 1995 and 96 that we were solving a problem, solving a book known as Irodov, and that other one was Krotov. There were three or four Russian books. They did not have any solution. Krotov did have solution, but Irodov did not have. And all the solutions were in the form, all the answers were in the form of algebraic expressions. So it would a b divided by c or something of that, f divided by m, 2 times f divided by m. There was no solution available for that book, and sometimes we used to get stuck. So we used to do reverse engineering. What do you mean by reverse engineering? Look at the answer and try to get to the question. Most of the time it worked, that we were able to get the question from the answer and we understood the concept. That is how I used to solve it. That was the last strategy that I had. But sometimes the reason that we used to give was so stupid that we knew that this is the stupid reason and this is the wrong reason, but this wrong reason is getting me the right answer. That is not the way I'm going to teach you. So answers are not important. You might get a right answer, but your process may be absolutely wrong. And I'm more worried about the process than the answer. So your answer is wrong, but what is the process? I'm worried about the process, not the answer. How did you get 4k x squared? Tell me.
Sir, spin constant is 2k and 2k, 4k nothing.
2 times k, 4k. So it is 4k x squared. That is the logic? Is that the logic? Okay. Anyone else would like to elaborate on the online class or offline class? Anyone has a different opinion about this? Karthik, Krishna, Reddy, Kevin, and the others in the offline class? Well, it's a straightforward answer. The energy stored, the elastic potential energy stored in the spring, the entire system is half k into x squared. So basically what I need to do is convert everything into one spring. Convert everything into one spring. So I did not draw the last step. The last step of representing this diagram, and that is what I suppose I wanted you to do that, but again you are not doing it, and that is the problem, that you are not able to do a single step on your own, and that is not a good sign. So this is the last step of this problem. What is the last step? What do I mean by the last step of this problem? This problem started from this diagram. I shall call it diagram number 1. This is diagram number 1. That was the problem diagram. That's how things started. Now, after solving first step, we get to the figure number 2. So I hope you can see figure number 2, where I have replaced 2 parallel springs by 1 spring. That is figure number 2. Now I have less space, so I have to move on to the last figure. From here, this is the last step where I get to the most basic of the steps. Step number 3, which I have marked in blue. This is the last step of this problem, where this problem has been solved completely. Now, this problem now becomes a simple problem that I have one spring attached to one block. What is the spring constant of this spring? Anyone? That I have drawn here. What is the spring constant of this spring that I have drawn here? What is the spring constant of this spring that I have drawn here? No one knows it? If no one knows it, then I am the worst teacher in the entire universe, which I don't think I am. What is the spring constant of this spring that I have drawn in step number 3? Oh, I hope you can see that step number 3. This is step number 3. What is the spring constant of the spring that I have drawn in step number 3? I hope you have seen the other 2 steps. Step number 1 was the problem figure. Step number 2 was I replaced parallel springs by one spring. And step number 3, I replaced everything with one spring. What is the spring constant of this spring that I have drawn in
K,
step
sir.
number 3? Yes.
K.
Yes,
sir.
chalo. I am not the worst teacher in the entire universe. K. And now what is the answer of the energy stored in the system?
Half kx square.
See, the answer was simple. Answer was right in front of your eyes. You did not see it. Most of the difficult problems are right in front of you eyes. So I just replace it by k effective so that both the things look different. The answer is half kx squared. And that is what I was looking for. See, the answer was so simple. I don't know from where did you get 4k and 5k and 6k and 2k. The answer is simply half kx square. So you did not draw the third step. You did not have to draw the third step. Once you understand the concept, maybe once I have drawn it, next time I may not have to draw it. The answer is simply half kx square. Do you all understand this, or is there any doubt in anyone's mind right now? Please speak
Clear,
up.
sir.
Clear. Okay. Now, let us go up. Let us increase the level of the questions that we can solve wrong. Now everything depends on how the question is asked. Now while I am displacing this block by an amount x, someone has to do work. It is not going to displace on its own. The springs are in their natural length. Even if you sit for an entire century or your entire lifetime, this block will not move on its own. Someone has to move it. Yes or no? Yes or no?
Yes, sir.
What is the work
Yes,
done
sir.
in moving this block? What is the work done in moving the block? Now, most of the times when this question is asked, now since you are JEE students, most of the time when this question is asked, remember this question is asked whenever someone says work done in moving this from here to here, work done. You will get many questions in the chapter on gravitation on this. You will get many questions in the chapter of electrostatics on this. Whenever and work power energy itself, we will be doing a lot of problems here on this. Whenever we are talking about work done in moving this block, it is always the block is moved very slowly. Now when I say very slowly, they basically means that the change in kinetic energy is actually equal to zero. So I'm just giving you this additional information that I'm moving it very slowly. And I'll try to explain why this change in kinetic energy, why this change in kinetic energy is zero, or why it is said to be moved very slowly. But right now, you don't concentrate on these two parts. You don't concentrate on these two parts. Forget, just imagine that you do not exist in your universe. You have no idea what is change in kinetic energy. They are moving very slowly. Forget about this. I just give you the question. Find out the work done in moving the block. What is your answer? And sometimes you know the answer, but you don't know why it is the answer. But still it is the answer, and you convince yourself, okay, this is the answer. Don't convince. Don't convince yourself. I mean, you should know the fact. And that is why I'm saying you this additional information, yellow information is not given to you. You're not worried about this information. The only thing that has been asked, find the work done in moving the block. What is the answer for this question? See, though books will not tell you all these things that I'm going to tell you. You will not find these things in any of the notes, and I will not ever give all these things in notes, because if I give everything in notes, you will not come to the class and you will not be able to understand what is happening in the class, and you will not be able to understand it by reading notes alone. That is why some things are only done in the class and they remain in the class. What is the work done in moving the block? It's as simple as that. You give me, I'll give you a minute to think about it. Remember, answers are not important. Answers are the least important things. But here, you can straight away tell me the answer. What is the work done in moving this block?
Minus half kx square.
Minus half kx square. Okay, I was not expecting a minus sign. Why do you think it is minus half kx square? Why not plus half kx square?
Change in potential energy equals to minus of work done.
Great. So basically what you are saying is, and that makes things interesting, change in potential energy is minus of work done. Are you saying this?
Yes, sir.
What is this? This is how we define the change in electrostatic potential, change in any potential energy, right? Now, do you recollect what was this work done by? Who was doing this work? Work done by what? Work done by God, work done by you, work done by me, work done by Mr. X, work done by Doraemon, Hulk. Who? Work done by what?
Ring.
Spring. If you're talking about spring potential energy, it is spring. If you're talking about gravitational potential energy, it is gravitation. If you're talking about electrostatic potential energy, it is work done by electric field or electric force. What am I asking you? Work done in moving the block. Right now, is the spring moving the block? No, the spring is not moving the block. It is someone else is moving the block. So I must have elaborated, and that is why I did not ask you. I
Minus
did not.
integral f into dx.
I did not tell you that this is the work done by some external agent, and in most of the times, maybe even in your JEE main exam, and it may not be mentioned that this is the work done by the external agent. Spring is not doing this work right now.
Minus integral f into dx.
Spring is not doing the work right now. It is the work done by the external agent that has been asked. I know that work done is negative, is the integral of f dx. That is not the point right now. The point is something else. So basically, I'm asking about the work done by the external agent, and the answer that you are giving me, the change in internal energy is negative of work done by the spring. So from here, I can find out the work done by the spring. Work done by the spring is equal to negative of change in potential energy, right? Yes or no?
Yes, sir.
What is change in potential energy? Negative of that I have to find out.
Half k.
Half kx square minus 0. Negative of that is minus half kx square. Now, bacha, tell me which work have you given me the answer of? Which work are you answering me? You are telling me the answer of? You are telling me the answer of work done by the spring. But what did I ask you? I asked you work done in moving the block. Spring is not moving the block. Someone else is moving the block. Otherwise, it will not go. Even if I sit till eternity, the block will not move on its own. Once I move it, then I leave it, then something will happen. That is a different issue. But first, I'll have to move it. Are you getting my point? Someone has to move it, else it does not move at all. Am I clear?
Can we apply work energy theorem?
Okay. Now you are coming there. I apply work energy theorem. What do I apply in work energy theorem here? How do I apply the work energy theorem here? That is correct. I apply work energy theorem here. Now, what does work energy theorem state? Let us first write work energy theorem. So far, so good. We have not taken a wrong step up till now, but we have not found out the answer for work done by the external agent. We have found out the answer of work done by spring, but that is not the question. Now, whenever such a question comes, you will have both the answers. You will have the negative answer, you will also have the positive answer. And intuitively, you will always mark the negative answer because you are getting negative, you are not getting the positive answer. That is where you are going to make a mistake, and that is where you are going to lose 5 marks. Remember, if you do a question wrongly, you don't lose 1 mark, you lose 5 marks. Now I apply work in nature. And what is work in nature? Tell me. What is work in nature? Tell me. Work in theorem states that work done by all forces should be equal to change in kinetic energy. Yes or no? Do we all understand this? The age-old work energy theorem. Nothing beats it. Can I have some raise hand that we understand it? Online student, offline students. Okay. Now, what are the forces at work here? Let us not use the forces that are not doing any work. Gravitational force is not doing any work. Forget about it. Normal force, gravitational force is downwards, not doing any work. Normal force is upwards, not doing any work. Then who is doing work? There are only two forces that are doing work. What are those two forces? That means the work done by the spring plus work done by the external force should be equal to change in kinetic energy. So is everyone going to raise their hands now again? That is the answer. Now you look at what was the yellow part that we had neglected. Do you see that yellow part now? Let us.
Delta chi is 0.
Yes, now that yellow part comes into the picture and that becomes
Work
the
done by
most
spring equals
important
to
part.
minus work done minus external work.
Yes, yes. Now you are getting it. Now you look at the yellow part. Now you look at the yellow part. The part which was not looking good at all, which was not making any sense. Now it becomes senseful. Because if the change in kinetic energy is zero, now I can find out something. This becomes zero. This means change in kinetic energy becomes zero.
Work done by spring equals to work done minus work done by external.
Yes, and this is a very important thing that you must remember. But this will only happen in one condition only. What is that condition? Change in kinetic energy is
0.
zero. You move the block, you move the body very, 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 very slowly. So slow that you don't find any change in kinetic energy. In some books, the definition of potential energy is given in terms of external work, which is absolutely wrong. You cannot define potential energy of a conservative force from an external force. Yes, beta? The potential energy of a conservative force can only be defined by work done by that force, not work done by some other force. Is there any doubt that you have here? I hope not. Now, give me the answer. What is the work done in moving this block by an external agent without changing the kinetic energy? What is the answer for your question now? What is the answer for the question that I asked? The work done by the external agent, and remember this question will come to you many
Half
times,
kx square.
is half plus half kx square. And whenever you have such a question, please remember that you will have both the options at your disposal. You will have the plus option as well as the minus option. So think before you mark it. Mark this question as important so that you remember the concept here. I told you from the very beginning, some questions will have some very important concept discussed in great details. Mark those questions so that whenever you want to revise, you should be able to do it fast. Is everyone clear with this question? Shall I move ahead? Okay.
Sir, clear.
Now, since you see, remember, we are not doing one question. I'm doing 5-10 questions in one question. So I don't just imagine that I've done one question. I'm doing 5-10 questions in this question. Okay.
Okay, sir.
Now I go one step ahead. Now let me name these springs. So let me call this spring as spring A, the first spring. Let me call this spring as B. Is there any problem, anyone? and let me call this spring as C. Do you see A, B, and C? A is the spring 2K, B is the upper wala spring, and C is the niche wala spring. Do we all get this? A, B, and C. Do you all see this? A, B, and C springs. Can I have some raise hand that you see A, B, and C springs? 3 springs. Instead of naming at 1, 2, and 3, I have named them as A, B, and C. Now let us get into the springs and see what is happening with the springs and try to make sense out of it. So there are 3 things that you have to tell me about these 3 springs. There are 3 things that you have to tell me about these 3 springs. Now let us, have you marked those 3 springs A, B, and C? So I can move on to the part where I can do other things. I hope you have marked these 3 springs. Now let me get to the questions part first. Question number 4, I think. Okay, A, B, and C springs have been marked. The 4th question that I'm asking is force acting on the block. Yes, beta. Yes? Any doubt? You mark those springs, right? So this is a very simple question, a 1-line question, which has a 1-line, a single line answer. What is the force acting on the block? What is the force acting on the block? It's a very simple question. What is the force acting on the block? Anyone in the online class, anyone in the offline class, can you give me the answer for this one? Straightforward question. No rocket science. What is the force acting on the block? And the answer is force acting on the block is simply equal to, if I talk about magnitude wise, the effective spring constant is K and the displacement is X. So if I say magnitude wise, it will be Kx. If I want to add direction, I will say reverse like this. So instead of writing the direction as reverse like this, I can write this arrow, as well as I can put a minus sign indicating that it is in the opposite direction, or it is in the negative X direction. Positive X is positive and negative X is negative. Do you understand this? Yes or no?
Yes, sir.
Why did not you give the answer then? It was a straightforward question. We're trying to understand everything that we need to know about springs in your entire 2 years of your preparation. Force acting on the block is minus Kx. Good. As I said, when you talk about springs, you're only concerned with 2 or 3 things in the spring. The first thing is definitely the spring constant of the spring, which is always known to you. How much is the spring constant of the spring? Everyone knows it. Then there are only 2 things that you are concerned about. The first thing is force, or you can, depending on how you see it, the first thing is the displacement. What is the displacement in the spring and what is the force acting on the spring? If you know any one of this, you can calculate the other. Yes or no? If I know X,
Yes, sir.
I can calculate F. If I know F, I can calculate X. Because K is already known. Yes or no?
Sir.
Apart from F and X, one more thing that could be asked to you is what is the energy stored in the spring? Yes or no? So basically, whenever someone is
Sir.
talking about spring, he is only talking about these 3 things, because K is normally known. You only need to find out K for effective spring constant, else K is useless. They are only going to ask you what is the force in the spring, number 1, what is the extension of the spring, number 2, and what is the energy stored in the spring. Mark this as an important question because these are simple. They are only going to ask you any 3 questions of this. And the good thing is, if you know any one of these, you can calculate the other 2. Yes or no?
Yes, sir.
That is the question now to you. You have to find out these 3 things for all the 3 springs. If you get only one of these correct, you should be able to do the other 2. Question number 5 is this: find displacement, force, and energy stored in each spring. When I say energy stored, remember energy does not have an absolute value. Only change in energy is defined. But in case of spring, the zero of energy is the actual zero. So in case of energy, in case of spring, I can always say energy stored in the spring. I don't have to say how much energy has changed. In terms of gravitational potential energy, whenever I say how much energy is at this height, I must tell you the ground level is zero. Otherwise, question does not make sense. But in case of spring, I don't have to elaborate where is zero energy, because we know zero energy occurs when spring is at its natural length. Am I clear? So these are the three questions. If you can get one, you can solve the other two. Let's see who can do this. Again, the answers are not important. When you are looking for an aim, when you are striving to get something in your life, when you are when you want to reach a destination, reaching the destination is your ultimate aim. After that, there is no aim. It's always the journey that has to be enjoyed. That's why I don't go in flights. I go in trains. Enjoy the journey. Flight, shoot, you will just reach. No enjoyment, no journey. Secondly, I'm scared of flights. I always used to get terrified when the plane used to lift off and land, and don't like to give my life in hands of people who I don't see. I hardly saw the captain of the plane, the captain of the flight who was flying me. If I don't see him, I don't trust him. Why I'm telling you all this? Journey is important. Answers are not. Can anyone tell me how do you find it? Give you 2 minutes. Then I'll give you some hints, and probably we'll discuss this question in the next class because it will take some time. What about the hints? How do you solve it? We'll discuss this. I'll give you 2 minutes, 1 minute to think about it. Am I audible and visible to all of you? I don't see your camera, the camera of the offline class moving. Online people, am I audible and visible to you? Karthik,
Yes, sir.
ready? I'm audible and visible to you. Good. That's a good sign. I think the offline class has just got disconnected. Anyway, doesn't matter. They might join. Think about how it is to be done. Well, well, what I will do is give you some hints on solving this question. How did I solve this question? Let us go back into that process. How did I solve this question? How I solved this question? everyone can see me. I was on step 1. Then I moved on to step 2. And then ultimately I moved on to step number 3. Step number 3. That is how I got the answer for effective spring constant. Now to solve this question from here, what do I need to go? I need to go up the ladder. So I start from position number 3. In position number 3, I know the spring is K and it is moved by a amount X. Spring is K, spring constant is K, and the spring moves by an amount X. Now from here, this spring was not one spring, but this spring was made up of 2 springs. This spring was made up of 2 springs which were in series. So if I know what was happening in spring number 3, I must be able to tell what will be happening in the 2 springs that were making spring number 3. So I move from step number 3 to step number 2 and solve step number 2. What do I do next? So I move from step number 3, where I have 1 spring, to step number 2, where I have 2 springs. Then from step number 2, I move on to step number 1. What is the difference between step number 2 and step number 1? This green spring. This green spring was not one spring. This green spring was made up of 2 springs. So I see what is happening with the green spring and then convert it to what will happen to the other 2 springs. And that is how we are going to solve this question. I'll give you time to solve it. In the next class, we will be solving this question. The offline class has been disconnected, but they have not lost on anything. I hope that you like this class. And I'll meet you in the next class day after tomorrow. If you have any doubts, please let me know. I'm here. Else, it is a wrap from my end. I hope you enjoyed the class. Take care. Have a very nice day and think about this problem, how you are going to solve it. Tata.